So last time we talked about higher order polynomials such as cubic and quartic. So if you look at this, I wanted to show you kind of different things that these things do one more time, just to give you an idea. Now notice this one is just a transformation of x cubed, and it's moved to the right 3 units and up 2, just like we did at the beginning of chapter 4. Now, if you look at this one cannot be written this way. So this one has these 2 turning points, 1, 2, and it actually crosses the x-axis 3 times and has 3 zeros. So if you had this in your calculator and you had to find all the zeros, you would have to do it 3 times to find it. This one only has 1, and this one only has 1, even though it does this. And there's all kinds of different scenarios. You can actually have a situation where it touches and does that. So if it touches right there, you can actually have 2, but that doesn't happen quite as often. And then here, these are my quartics, and of course this one is just the graph of x to the 4th, and then flipped over, because this is negative out here, it's moved over to the right 1 unit, and it's moved up 1 unit. So that's just a transformation. This one can't be written that way, so that one gives you that W shape, and then this one gives you kind of a weird shape. Crosses the x-axis twice, but it has this weird place right here that kind of does this odd looking thing. Okay, so let's talk a little bit about even and odds. And that kind of brings me to, we've kind of done this before back in chapter 4, but if the sign of the leading coefficient is positive and the degree is even, the end behavior is up. Here the end behavior is 1 up, 1 down. If it's negative, the end behavior is both down. And this is 1 up, 1 down, but it goes up on the left side and down on the right side. So these are really good ways to remember what it might look like, and we might be able to say, okay, what is this graph of this basically going to look like, or give me an idea of what a graph is going to look like. So let's start with a very, very important thing, which is the fundamental theorem of algebra. And all of these statements means exactly the same thing. If I have some function f of x, and I factor f of x, and I have something else, some blah, blah, blah in here, and then I have x minus a right here, and this comes out perfectly. X minus a is a factor, so that's what that means. X minus a is a factor of f of x, is the same as saying a is a function. Because of the zero product property, of course, this is equal to 0. So a is a 0 of the function. A is the real solution to the equation f of x equals 0. A is an x-intercept, because 0 and x-intercept mean the same thing. And the graph crosses the x-axis at the point a0. Okay, all of these things mean exactly the same thing. And this is what fundamental theorem of algebra tells us. And we kind of understand that because it means that x minus a equals 0, so x equals a. So when f of x equals 0, x equals a. This is all meaning the exact same thing. So let's talk about how we can find zeros of higher order polynomials. So in this case, we're given that a polynomial, after it's factored, is x minus 2 times x minus 1 times x plus 4. So if we find the zeros of p of x, since x minus 2, x minus 1, and x plus 4, or I can write it as x minus negative 4, are all factors of p of x, that means my 0 is 2, 1, and negative 4. That's it. The solutions to p of x equals 0, x equals 2, 1, or negative 4. The x-intercepts of the graph, Why does it say 5? Because that's the wrong graph. Okay. I think there's a typo. I think that was supposed to say 5. I think we have a typo in our midst, so I guess it's supposed to be 5, because if I look at my graph, it's 5. So let's fix that to 5. Okay. So, -4, 1, 5. Okay, so let's solve by factoring using, remember the zippy, the zero product property. So, let's look at this. Remember when we factor, the first thing that we do is, can we take something out of everything? We ask ourselves this question. And this question is, yes, in this case, I can take an x squared out. And what am I left with? X squared minus 4x plus 4 equals 0. And now can I factor the trinomial that's left? X minus 2, and I believe that's x minus 2 squared, because this is a perfect square, this is a perfect square, and this is 2 times x times 2. So that equals 0. So that means that x is either 2 or 0. And we also have this idea of multiplicity. Because this is squared, it has multiplicity. Each have what we call a multiplicity of 2. Because 2 happens twice and 0 happens twice. And what I mean by that, if we looked at the graph of something like this, and I'm going to actually Desmos this guy, just because it's better that way. So I'm going to look at the Desmos, and let's put that in. X to the 4th. Okay. Minus 4x cubed plus 4x squared. Now I'll show you what multiplicity means. Multiplicity means that if you look right here, I can't, there. If you look right here, that the turning point occurs on the x-axis. That's essentially what that means, is a turning point. If it's a multiplicity of 2, it means that a turning point is occurring on the x-axis like this. And so that's an idea of how we can see that and what we mean by that. Okay, so this means that the turning points are on the x-axis at 0 and 2. So let's look at this one. Now I first asked myself that question. Can we take something out of everything? Well, no, it's not a trinomial. So the next thing I'm going to try is factor by grouping. So I'm going to look at these two. Can I take something out of these two? Why, yes, I can take an x squared. So I'm left with x plus 5. And could I take something out of these two that I end up with an x plus 5? Well, I think I can take a minus 4. So what I end up with is x squared minus 4 times x plus 5. And then I'm noticing that x minus 4 is a difference of 2 squares. Okay, let's try that. X plus 2, x minus 2, and then we still have the x plus 5. So now we know that each 3 of these things are factors of this polynomial, which when set to 0, that means that it's -2, +2, and -5 are factors. And that is the solutions. So x can be any one of those things. So let's do an example using our applications. The total cost of producing a product is given by the function, oh, it's a cubic cost function now, where x is the number of hundreds of units produced. How many units must be produced to give a total cost of 55,000? So we're looking at x cubed minus 15x squared plus 5x minus 20 equals 55,000. Now, I could, let's see if this is factorable. I'm going to do it by hand. 5x minus 5520. So I'm going to look at this first one and I'm going to say, can I take something out of these two? Oh, $1,000. Ooh, see, we almost messed up. So give a total cost of 55,000. So shouldn't that equal 55? Because this is in thousands of dollars. Remember when I'm always telling you to be careful and read carefully about the units. That's why I said something's not right here, right? Okay, so now I have minus 55. Oh, that makes so much more sense because now I can factor it. So I can factor an x out of these two, x squared minus 15. And then out of these two, can I factor something out where I'm, factor out x squared, I'm sorry. Can I factor something out of these two where I get x minus 15? Well, what if I factor out 5? X minus 15. So what I end up with is x squared plus 5, x minus 15 equals 0. So I know that x plus 5, that's not real. So it doesn't really matter. It's not factorable. So then I know that x must be 15. So that's my answer. So it's x is, and it gives the number of hundreds of units. So the answer to this is how many units, and 1,500 units give a total cost of $55,000. So let's talk about the root method. Now we've done this before. We've done this with square roots before, but I can do this with any root. If I can get only the x or a binomial, this only works if the power is the only x term, or if it's inside a binomial. So what do I mean by that? Well, x cubed equals 64. I can take the cube root of both sides of this, right? So x equals the cube root of 64. What cubed is 64? The answer is 4, by the way. I know that it's positive because if it's an odd root, I don't have to worry about plus or minus. Now let's look at this one. Let's isolate this. So we have x to the 4th equals, what's 245 divided by 5? Let's see. 245 divided by 5, 49. So that means if I take the 4th root of both sides of these, that means that x equals, now here I got to do plus or minus because I have an even root. Plus or minus the 4th root of 49. Well, I can fix that a little bit because I know that I have x equals plus or minus. I can make that the 4th root of 7 squared. And if you think about that for a second, the 4th root of 7 squared, let's think about that as 7 to the 2 fourths, which is also 7 to the 1/2. So that's plus or minus the square root of 7. And there you go. Okay, so let's look at this next one. C, 6x squared equals 32. We've already done squares. So that means x squared equals 32 divided by 6. Let's see, let's divide the top and the bottom by 2. That's going to be 16 over 3, right? So that means x equals the square root of 16 over 3. That's plus or minus because it's even. So it is plus or minus 4 over the square root of 3. And that's it. Or if it really bothers you to have them in the denominator, you can do that. Okay. Next one. So let's look at this. Future value of an investment. We're going to talk a lot more about this. So the future value of $2,000 invested for 3 years at an interest rate R compounded annually is given by the equation S equals 2,000 times 1 plus R cubed. Find the rate R as a percent for which future value is 2,282.33. So we have an equation. Okay, so we want to isolate this cubic term. Divide both sides by 2,000. So we have 2282.33 divided by 2,000 equals 1.14. So we'll say 1. That equals 1 plus R cubed. So now what I want to do is take the cube root of both sides. Okay, so I'm going to take the cube root of this answer. So remember, cube root, you can find it under math number 4 right here. And I can just say second negative brings up the previous answer. So this is 1.045 equals 1 plus R. Subtract 1 from both sides. R is equal to 0.045 or 4.5%, because I can move the decimal place over twice. So the rate, if the future value is $2,282.33 and the amount invested was $2,000, I can locate the rate was 4.5%. And it was invested for 3 years. Got to remember that too. Okay. And I just want to also point out, you can always graph these and find them out too. So you can always check your answers. If I wanted to, 2,001 plus x math cubed. And then set that equal to 2282.33. And let's see. We know x is going to be very tiny, so let's set our window so we can actually see something here, right? So we know our x is going to be, we're going to say between 0 and 1. I know that sounds really crazy, but that's what we're going to do. And then our y min has to be over 2,000. So we'll go up to 3,000, just so that we make sure we cover this number. Let's see what we have. Ooh, that didn't work very well, did it? But it gave me the intersection I want. So there's the intersection. 1 was even too much. So we have the intersection. So I could actually go to number 5. First curve, second curve, and move my cursor over there. Come on, get over there. There we go. 0.045. And so that checks my answer. Okay. So the next thing I want to talk about is polynomial division and synthetic division. So what we're going to use, we're going to be solving cubic or more equations using division and synthetic division. Now, I teach you this. One of the reasons that I do this is because I think it's extremely important for applied calc that you know how to do this. It has other uses, of course, but sometimes you can't integrate something unless you can perform the division on it. So it's kind of important to be able to do. So let's talk first about long division of polynomials. Now, I want to talk first about long division. So let's say, for the sake of the argument, that I wanted to divide 35 through 30, I'll just say that for right now, and I want to divide that by 11. And I want to remind you guys how we would used to do that in the old days, right? So long division, we look at just the first two numbers right here, sometimes just the first number, and we say, how many times would 11 go into 35? We go 3, 33, then we subtract 33 from 35, 2, and we bring down the next number, 23. So how many times does it go into 23? That's 2, 22, 1, bring down the next number. Uh-oh, we can't do it, so we put 0 there, 0, 10. So the answer is 320, and then you could put this on the other side, and 10 11ths. And you could do that. Remember the other way, we used to bring down the 0 and then to go from there. That's okay. Right now we're just going to talk about what we would do with the remainder as far as making it something like this. So let's do that with polynomials. We can do the exact same thing. So we make sure that underneath we have a polynomial that isn't missing any x terms, and this one isn't. We go all the way from 3, 2, 1, 0. So we have x cubed, x squared, x to the 1, x to the 0, because anything to the 0 is 1, right? And we literally make a division symbol, x minus 1. So now what we do is we look at this x, and we look at this 3x cubed, and we say, what times x would be 3x cubed? So we're going to say 3x squared. So 3x squared times x is 3x cubed. Now we multiply it by the second part, minus 3x squared. And again, we're going to subtract this from what's before it. So negative 5x squared minus negative 3x squared. So remember, this becomes a, now we can get rid of these parentheses. This becomes a minus and plus if we get rid of the parentheses. So we have negative 5x squared. This should be 0, and it is. And just like in regular division, we bring down the next one. So now we look at negative 2x squared, and how many times we need x to go into that. So we need minus 2x. Negative 2x times x, negative 2x squared. Negative 2x times negative 1, positive 2x. Again, we're going to subtract what's inside these parentheses. So we just change the sign, plus, this becomes minus. This goes to 0. 3x minus 2x is x, minus 10. So now x to x is just 1. So now we're just going to go x minus 1. And again, change the signs, negative 9. So just like before, now we have a minus 9 over x minus 1. And we can find out some things. Now we know some things. We know since there's a remainder, we know that x minus 1 is not a factor of 3x cubed minus 5x squared plus 3x minus 10 by the fundamental theorem of algebra. And we also know that that p of 0 is not equal to 1 because we did x minus 1. So we know this about this information. And we have this, now we have this new one. In fact, what's really cool is actually f of 1 is negative 9, which is kind of a really cool result because whatever you get right here, whatever that is, that's what f of 1 is, and that's a really kind of a cool thing. I can prove that if you want. 3 times 1 cubed minus 5 times 1 squared plus oops, plus 3 times 1 minus 10. So this is 3 minus 5 plus 3 minus 10. So let's see, we have 3 minus 5 is negative 2, plus 3 is 1, minus 10 is negative 9. What? Isn't that cool? The remainder that you get in polynomial division is actually the f evaluated at that number right there. So that's kind of a neat result. And that's only if this doesn't have anything. If this is 1, that only works. So kind of a cool thing. So let's talk a little bit about synthetic division. This is a bit of just a shortcut to our division problem. And, you know, I go back and forth whether I teach this or not. I really like it, so I go ahead and teach it. So the first thing we do is we arrange the coefficients in descending powers of x, and that's the coefficient of p of x, and put a 0 as a placeholder for any missing. So we're going to look at this. Do I have anything missing in this case? And I'm just going to arrange the coefficients. So if I rewrite this, I have x to the 4th, I have x cubed, but I don't have an x squared. So I just put 0 as a placeholder, 6x minus 4. So what I'm going to do is I place 2, 5, 0, negative 6, negative 4. And then I put a little L right here, a little backwards L, I guess. And then place the a from x minus a. Well, this is x minus negative 2. So a is negative 2. So this is the first step. Now, my next step is going to be part 3. Bring down the first number on the right side of the barrier under the horizontal line. I put a horizontal line, I forgot that. So bring down the first number on the right side of the barrier, right here. Bring down this under the horizontal line. That's the next step. Step 4, multiply the number you brought down by your, okay, I know how to spell your, I don't know, that's a big typo right there, sorry. Go away, you dumb thing. Okay, by your a, not you are a. Your a, so your a is right here, so you go 2 times negative 2 is negative 4. And place that directly under the second number to the right of the barrier above the line right here. Now, step 5, you're going to add the two numbers in your column, the column you just created, and place that sum under the horizontal line. So 5 minus 4, 5 plus negative 4 is 1. Okay, step 6, repeat steps 4 and 5 with the next numbers in order. So 1 times negative 2, so we're back to the multiply one. So we're at this one. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. We add going downward, negative 2. Another negative 2 times negative 2 is positive 4. Negative 4 plus 4 equals 0. Okay, so once we finish and get all the way through, write your new polynomial, starting from 1 degree less than your original. If the last number is 0, you have no remainder. But if the last number is not 0, then you write the last term as the remainder divided by x minus a. In that case, note that a is not a 0 of the given polynomial. So let's see what we have up here. So here we start with 1 less. So remember, what was this? This was a 4th power. This was 4th, 3rd, 2nd, 1st, and this was our constant. Okay, so now we go 1 less power. So this is now 2x cubed plus 1x minus 2x squared minus 2x minus 2. So this is what we actually have left over. And we have a 0 at the end, so we'd have no remainder. And that also tells me that negative 2 is a 0 of my polynomial, and I can factor this, so my p of x can be factored like this. Now what I would do, if I want to completely factor it, is I could look at this and see if there's anything that I could do with that. And I don't think there is immediately. I don't see anything where it can be factored immediately. So I know that negative 2 is one of the factors of this. So let's do another one of these. So we're just going to divide these. I'm going to use synthetic division. So do I have anything missing? 4, 3, 2. Oops, I don't have a 1. So I have to remember 0x right there. So I have a 1, a 2, a negative 3, a 0, and a 1. And down here, remember this is x minus negative 4. So I'm going to do this division. Bring down my 1. 1 times negative 4 is negative 4. Negative 2 times negative 4 is 8. 5. 5 times negative 4 is negative 20. So that's negative 20. Negative 20 times negative 4, whew, that's 80. So this is 81. So my division comes out x cubed, because that's 1x cubed, minus 2x squared plus 5x minus 20 plus 81 divided by x plus 4. And I can also find out that if this at negative 4 is 81, because if I had negative 4 to the 4th plus 2 times negative 4 cubed minus 3 times negative 4 squared plus 1. So that's 64 plus, let's see, no, that's more than 64. That's 256. Plus, that's 64 times 2. That's 128. So we're at 128 right now, right? Minus 3 times 16, which is 48, plus 1. Oh, wait, that should be minus. I'm sorry. Because it's negative 4 cubed. So it looks like we have 128 minus 48 plus 1. Well, 128 minus 48 is 80, plus 1 is 81. So you can do that way too. It's kind of a cool result. Okay, so finding the solutions of polynomials. So this tells me, so a lot of times this is what we're going to have. Given that negative 1 is a solution of the above polynomial, find the rest. So we're told that negative 1 is a solution. So we know that if we go negative 1, so x plus 1 is what we're dividing. If we divide this by x plus 1, we know this can be factored as x plus 1 and something else. And then if we can factor that something else, we can find the rest of the solutions. So let's divide this by x plus 1 using synthetic division. So let's see, x cubed, x squared, we have an x, and we have a constant. So we have nothing missing. So bring down the negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. 2 times negative 1 is negative 2. That's negative 1. Negative 1 times negative 1 is 1. 0. Well, good. They didn't lie to us, because we got the 0 over here. So this means we end up with negative x squared plus 2x minus 1. So that's what this looks like. So we can factor it this way. Now I can factor this further. Let me factor out a negative 1 out of it. X squared minus 2x plus 1. Hey, that looks like something I can factor. So negative x minus 1 squared, correct? So that means the other solutions are positive 1 and positive 1, or just positive 1. And positive 1 has a multiplicity of 2, which means that if I were looking at this, this is a negative. So if I get an idea of what this looks like, it's going to go down on this side. And then it turns around at 1. So this is, let's say this is 1. And then comes back up, see this is 0 right here, and then comes back up at -1. It probably looks something like that. And there's where it crosses. It crosses this one kind of as a max point and then goes like that. So we can get just an idea of what it might look like in our heads. Okay. Whoa, is that all I've got? I guess that's all I've got for today. All right, that's it. There's only 35 minutes. So we will practice a few more of these in class also, so no worries.